On December 5th, 1945, 5 American torpedo bombers took off from a naval air station in Fort Lauderdale, Florida, on a routine training exercise over the Atlantic Ocean. 14 men were aboard those planes. The mission was supposed to last about 2 hours. Somewhere over open water, the flight leader's voice came through on the radio, and it did not sound like a man following a routine flight plan anymore. His compass was malfunctioning, he said. He didn't recognize the ocean beneath him. He didn't know which direction led back to land. Within hours, all 5 aircraft were gone. Not damaged, not diverted. Gone, along with every man aboard them. And when the Navy launched a search plane with a 13-man crew to find them, that plane vanished too, in the same stretch of ocean, the same night. 19 additional men lost searching for the 14 who never came home. To this day, not one piece of wreckage from any of those 6 aircraft has ever been recovered. Not a scrap of metal, not a single body, nothing. This is the case that, more than any other, built the legend of the Bermuda Triangle into what it is today. And for decades, it has been told as a story of the supernatural, of forces beyond human understanding, swallowing ships and planes whole. But here's what almost nobody tells you when they tell that story. Scientists have spent the last several decades quietly, methodically pulling this mystery apart piece by piece, and what they have actually found is stranger, more grounded, and in some ways more unsettling than any ghost story could ever be. Let's start with something that might genuinely surprise you, something that almost never makes it into the documentaries and viral articles that keep this legend alive. The Bermuda Triangle, as a specific, defined region of ocean, does not officially exist. There is no government agency, no international maritime body, no scientific organization anywhere in the world that recognizes an official boundary for it. The area most commonly associated with the name, roughly a triangular region stretching between Miami, Bermuda, and Puerto Rico, was never defined by oceanographers or the Navy. It was defined, almost accidentally, by writers. The term itself wasn't even coined until 1964 in a magazine article by writer Vincent Gaddis, nearly 2 decades after the loss of that training flight. And depending on which book or article you read, the boundaries of the triangle shift dramatically, sometimes covering roughly 500,000 square miles of ocean, sometimes stretching to cover well over 1 million. If the boundaries of a supposedly deadly supernatural region of ocean can be redrawn depending on which author is writing about it, that alone should tell you something important about how this legend was actually built. And here's the second thing that rarely makes it into the retelling. The United States Coast Guard, the government body directly responsible for maritime safety and search and rescue operations in this exact stretch of ocean, has stated publicly and repeatedly that it does not recognize the Bermuda Triangle as an area of unusual danger. Lloyd's of London, the centuries-old marine insurance market that literally makes its money calculating risk for ships crossing every ocean on Earth, has conducted its own reviews of the data and found no statistical evidence that this region experiences a higher rate of shipping losses than any other similarly sized, similarly trafficked stretch of ocean anywhere in the world. Read that again. The organization whose entire business model depends on accurately pricing the risk of maritime disaster looked at the numbers and found nothing unusual. If the Bermuda Triangle actually consumed ships and planes at a supernaturally elevated rate, it would be the single most expensive body of water on the planet to insure a vessel to cross. It isn't. So if the statistics don't support a curse, why does this place still capture the imagination of millions of people, decade after decade? Partly, it's simple math, working against our intuition. This is one of the busiest stretches of ocean on the planet, sitting directly along major shipping lanes between North America, the Caribbean, and Europe, and directly beneath heavily trafficked commercial and private air routes as well. More ships and planes pass through this region than through almost any comparable area of ocean anywhere else on Earth. When you have an enormous volume of traffic passing through the same region year after year, for over a century, you are, simply through sheer numbers, going to accumulate a certain number of accidents, disappearances, and unexplained losses over that time. The same way a busy highway intersection accumulates more total car accidents over decades than a quiet rural road, without that intersection needing to be cursed. Add nearly 150 years of maritime and aviation history to a route this heavily used, and you get a long list of genuinely tragic, genuinely unexplained losses. The mistake, the one that turned a statistical pattern into a modern legend, was assuming that a long list of incidents automatically means something supernatural is causing them, rather than simply reflecting how much traffic has passed through this water in the first place. But explaining away the volume of incidents doesn't fully explain the individual cases, and this is where the actual scientific detective work gets genuinely interesting. Because researchers studying this region have identified several very real, very physical phenomena that converge here in ways that don't occur nearly as often anywhere else on the planet. The first one involves something most people have never thought about in their entire lives: the difference between true north and magnetic north. Every compass on Earth points not toward the geographic North Pole, the fixed point at the top of our planet's rotational axis, but toward magnetic north, a constantly shifting point determined by the movement of molten iron deep within the Earth's core. In most parts of the world, there's a measurable, sometimes significant difference between these two directions, known as magnetic declination, and sailors and pilots have to calculate and correct for that difference constantly to navigate accurately. But there are a small handful of locations on the entire planet where true north and magnetic north line up almost perfectly. Locations sitting along what's known as the agonic line, where a compass, for once, actually points toward the real geographic North Pole with essentially zero correction needed. The Bermuda Triangle happens to sit directly along one of these rare agonic zones. For most of maritime history, this wasn't dangerous. It was actually useful, one of the few places on Earth where a compass told you the unadjusted truth. But it became a genuine hazard in a specific, narrow window of navigational history. During the transition from purely magnetic compass navigation to more advanced instruments, sailors and pilots trained to always expect and manually correct for a declination gap, sometimes overcorrected in this specific region, applying an adjustment that wasn't actually needed here, and steering confidently in a direction that was subtly, quietly wrong. It's a small, technical error, the kind of mistake that sounds almost too mundane to explain a disappearance. But over open ocean, at night, in bad weather, with no landmarks to check yourself against, even a small, confidently held navigational error compounds mile after mile, hour after hour, turning a minor miscalculation into a genuine catastrophe. This is, in fact, almost precisely what official investigators concluded happened to that training flight in 1945, the one that built this entire legend in the first place. The flight leader that day, an experienced instructor, reported that his compasses were behaving erratically, and rather than falling back on basic backup navigation procedures, he apparently grew increasingly convinced he knew the correct direction back to base, leading his formation further out over open water as the weather deteriorated and daylight ran out. The official Navy investigation into the loss ultimately attributed the disaster primarily to navigational error, compounded by worsening weather and fatally dwindling fuel that left the aircraft with no option to simply wait out their confusion until morning. It is a tragic, human, entirely explicable sequence of small errors compounding into disaster, not a supernatural void that swallowed 6 aircraft and 33 men without a trace. The reason no wreckage was ever found isn't because something otherworldly erased it. It's because the ocean in this region is thousands of feet deep in many places, subject to powerful currents capable of scattering and burying debris quickly. And the search technology available in 1945 was nowhere near sophisticated enough to locate wreckage across the vast area those planes could plausibly have gone down in after running out of fuel in the darkness. Which brings us to the second major natural factor scientists point to when they study this region, the Gulf Stream. This is not some minor regional current. It's one of the most powerful ocean currents on the entire planet, a river of warm water flowing through the Atlantic Ocean at speeds that can exceed 5 miles per hour, carrying more water than all of the world's rivers combined. It runs directly through the Bermuda Triangle region on its path northward along the eastern coast of the United States, before curving out across the Atlantic toward Europe. A current this powerful does 2 things that matter enormously to this story. First, it can dramatically and rapidly disperse wreckage, debris, and even life rafts across huge distances in a remarkably short window of time, meaning that search efforts looking for a vessel or aircraft in the location where it was last reported may already be searching in completely the wrong place by the time rescue crews arrive, because the current has carried everything miles away in the interim. Second, and just as important, the Gulf Stream is directly responsible for generating sudden, violent, and highly localized weather. Where warm Gulf Stream water meets cooler surrounding ocean water and colder air masses, conditions are ideal for rapidly forming squalls, waterspouts, and severe, fast-developing storms, weather systems that can appear with very little warning, especially to a vessel or small aircraft without access to modern satellite forecasting. And this leads directly into what may be the single most compelling natural explanation scientists have proposed in recent years: rogue waves. For most of modern maritime history, the idea of a single, isolated wave rising 80, 90, even over 100 feet high, appearing suddenly out of relatively normal seas with no warning, was considered close to a maritime myth, a sailor's exaggeration passed down through generations of sea stories. Classical ocean wave physics, the mathematical models oceanographers relied on for most of the 20th century, predicted that waves of this size and suddenness simply should not occur except perhaps once every 10,000 years. Then, in 1995, a wave measuring around 84 feet struck an oil platform in the North Sea, and its height was recorded by scientific instruments, not by a sailor's shaken recollection after the fact, but by hard data. It wasn't a myth. It was real, measured, and undeniable, and it forced oceanographers to fundamentally reconsider what the ocean was actually capable of producing. Since then, satellite radar data, gathered as part of major international ocean research projects, has confirmed that rogue waves occur far more frequently across the world's oceans than classical models ever predicted. And researchers studying the specific conditions of the Bermuda Triangle region have proposed something genuinely compelling. This stretch of ocean sits at a convergence point where storm systems from the Gulf of Mexico, the wider Atlantic, and the Caribbean can all interact and overlap in a relatively small geographic area. Oceanographers, including researchers associated with the University of Southampton in the United Kingdom, have used laboratory wave tanks and computer modeling specifically to simulate what happens when multiple storm systems converging from different directions combine their wave energy in exactly this kind of overlapping pattern. Their simulations demonstrated that under the right conditions, converging wave trains from separate storm systems can combine to produce single waves reaching heights of around 100 feet. Waves capable of striking a vessel with almost no warning and enough force to break even a large, well-built ship in half, or capsize it within seconds, far too quickly for a distress call to be sent, let alone a search to be launched before the vessel and everyone aboard it disappeared beneath the surface entirely. This single piece of research, more than almost any other modern finding, has reshaped how oceanographers talk about disappearances in this region, because it offers something the supernatural explanations never could. A mechanism by which an experienced crew on a seaworthy vessel, in what appeared to be survivable conditions, could vanish almost instantly, leaving behind no time for a mayday call and very little wreckage that would necessarily wash ashore or be spotted by search planes afterward. There is one more theory, more speculative than the others, but persistent enough in scientific discussions of this region that it deserves to be addressed honestly, including its genuine limitations. Beneath significant portions of the seafloor in and around the wider Atlantic continental shelf, including areas associated with the Bermuda Triangle, geologists have confirmed the existence of large deposits of methane hydrate, sometimes nicknamed fire ice, a crystalline structure formed when methane gas becomes trapped within ice under the specific combination of cold temperature and immense pressure found deep on the ocean floor. The theory, first popularized decades ago and still occasionally revisited in scientific literature, proposes that a sudden large-scale release of trapped methane gas from the seafloor could dramatically reduce the density of the water above it, potentially causing a vessel to lose buoyancy rapidly and sink with startling speed, while the rising gas cloud, if it reached the surface and drifted upward, could theoretically interfere with aircraft engines flying through it as well. It's a genuinely fascinating hypothesis. And methane hydrate deposits are absolutely real, well-documented geological features found in numerous ocean regions around the world, including areas geologists have specifically surveyed off the eastern coast of the United States. But here is where honesty matters more than a satisfying story. When the United States Geological Survey specifically investigated whether a methane release event on the scale required to sink ships could plausibly explain Bermuda Triangle disappearances, geologist Bill Dillon, who led relevant research into the region's seafloor geology, found no evidence of any large-scale methane hydrate eruption having occurred in this specific area within at least the last 15,000 years. The theory remains scientifically plausible in principle. Methane release absolutely can and does affect water density, and has been documented causing exactly this kind of danger in other parts of the world, most notably in the North Sea, where researchers have mapped seafloor craters left behind by past methane eruptions. But applied specifically to the Bermuda Triangle, it currently remains an interesting unproven hypothesis rather than a confirmed explanation. And any honest account of this mystery has to be clear about that distinction rather than presenting it as settled fact. What's genuinely fascinating when you step back and look at all of this together is how the actual scientific picture of the Bermuda Triangle has evolved. It didn't start with scientists. It started with sailors' folklore stretching back centuries, with even Christopher Columbus reportedly noting strange compass behavior and unusual lights on the horizon while sailing through this exact region on his very first voyage across the Atlantic in 1492. An account that, once you understand the agonic line and the region's unusual magnetic properties, suddenly makes a great deal more grounded sense than it did as a mysterious historical footnote. The legend was then dramatically amplified in the 20th century by writers capitalizing on genuine tragic losses like that 1945 training flight, and by a 1974 best-selling book that compiled dozens of incidents together into a single ominous narrative without applying much scientific rigor to any individual case. And only in the decades since has the scientific and oceanographic community systematically gone back through the same list of cases, incident by incident, applying real data, real statistics, real oceanography, and real navigational history to sort out what actually happened. What they have found is not one single tidy explanation that solves every case at once. It's something more honest and, frankly, more interesting than that. A region where several genuinely rare and dangerous natural phenomena happen to overlap. A stretch of ocean sitting on one of Earth's few agonic lines, where compass navigation carries unusual risk of quiet, compounding error. A powerful, unpredictable current capable of scattering evidence and generating sudden severe weather with little warning. A geographic convergence point for multiple storm systems, creating precisely the right conditions for the kind of rogue waves that classical science denied were even possible until measured data forced everyone to reconsider. And underlying all of it, simply an enormous volume of ships and aircraft passing through the same relatively small area for well over a century, guaranteeing that even a normal, unremarkable statistical rate of accidents would still produce a long, unsettling list of names, dates, and disappearances over that much time. None of this makes the individual losses any less tragic. The 14 men aboard those training aircraft in 1945 were real people, with families who spent the rest of their lives without answers about what happened to their sons, husbands, and fathers. The crew of the USS Cyclops, a massive Navy collier that vanished without a trace in March of 1918 with more than 300 people aboard, remain, to this day, the largest single loss of life in United States naval history outside of combat. And not one piece of that enormous vessel has ever been found, despite decades of searching. What makes that particular loss even stranger and worth understanding rather than mythologizing is that two sister ships built to the exact same design as the Cyclops were later lost, in similarly severe circumstances, in the same general region years afterward, a pattern that pointed investigators not toward the supernatural, but toward a possible structural design flaw in that specific class of vessel, something entirely explicable through engineering, even if the full details were never conclusively proven before all three ships and their crews were already gone. This, ultimately, is what makes the real scientific story of the Bermuda Triangle more compelling than the supernatural one, at least to anyone willing to sit with a more complicated answer than something otherworldly lives out there. The ocean does not need ghosts, curses, sea monsters, or forces beyond human comprehension to be genuinely, legitimately dangerous. It has rogue waves capable of snapping ships in half within seconds. It has currents strong enough to erase almost every trace of a disaster before rescuers can arrive. It has one of the only regions on the entire planet where a basic tool like a compass can quietly betray the very sailors who trust it most. And it has, running beneath a huge percentage of everything we now understand about this legend, simply an old, deep human tendency to look at tragedy without an immediate explanation and reach instinctively for mystery rather than mechanism. Because mystery, in its own strange way, can feel more bearable than a string of ordinary, explicable, preventable errors compounding in the dark over open water, with no one left to tell us exactly how it happened. Science hasn't erased the Bermuda Triangle's power to unsettle us. If anything, understanding the real forces at work out there, the waves, the currents, the compass lines, the storms converging from three directions at once, makes clear that the ocean itself, without any help from anything supernatural, remains one of the most genuinely unpredictable and dangerous environments on our entire planet, and it always has been. If you want to keep exploring the real stories, real science, and real mysteries still hiding beneath the surface of our oceans, make sure you're subscribed, because there is a lot more of this world left to uncover, and you won't want to miss what we dive into next.